Artificial intelligence, AI, has evolved from a niche academic pursuit to a transformative force that challenges our understanding of intelligence itself. With rapid developments in computing, machine learning, and robotics, AI is now approaching thresholds that many experts once deemed science fiction. This video explores the singularity, a future moment when AI becomes smarter than humans. Such an event would mark a dramatic shift in technological and societal paradigms. We begin by examining the critical milestones in AI history, noting how exponential growth in data processing and algorithmic sophistication paved the way for the potential emergence of a superintelligent entity. Our discussion will cover key breakthroughs, such as the evolution from symbolic AI to deep learning networks, and how these successive innovations have accelerated our progress toward true artificial general intelligence. The singularity is not merely a speculative scenario. It is grounded in advanced statistical models and complex systems analysis. Many experts believe that once artificial entities are capable of recursive self-improvement, the pace of technological innovation will become uncontrollable and eventually surpass human cognitive abilities. This raises profound questions about control, ethics, and the future balance of power between humans and machines. In this script, we adopt a relaxed, friendly tone while maintaining rigorous technical detail. Our aim is to provide deep insights, supported by numerical analyses and factual data, that will engage experts in the field. Join us as we navigate the historical context, technical underpinnings, and ethical implications of a world where AI outsmarts us, and consider the practical ramifications of living alongside entities that may someday exceed human intelligence. Throughout this discussion, we delve into technical specifications, algorithmic improvements, and breakthrough research studies to illuminate each facet of the potential singularity. We challenge traditional perspectives and explore innovative models that quantify progress and forecast future trends remarkably. Tracing the evolution of artificial intelligence reveals a landscape of relentless innovation and increasing complexity. Early pioneers laid the very foundations of computing and algorithmic theory, paving the way for future breakthroughs. In the 1950s, luminaries proposed the initial framework for perceiving machines as capable of logic and pattern recognition. This period saw seminal ideas, such as Turing's test, which questioned a machine's ability to mimic intelligent behavior. The subsequent decades witnessed a series of transformative phases. The 1960s and 1970s introduced symbolic and rule-based systems, setting the stage for expert systems that simulated reasoning in limited domains. The rise of computational power, combined with advancements in software engineering, enabled these systems to operate within narrowly defined tasks. By the 1980s, neural networks emerged, though early models struggled with computational limits. Entering the 1990s and the early 2000s, the confluence of big data, increased processing capabilities, and refined algorithms brought forth a renaissance in machine learning. Noteworthy milestones include the development of support vector machines and decision trees, precursors to the more sophisticated deep learning models that dominate today. Furthermore, innovations in hardware, including the advent of GPUs, accelerated training times and enabled larger, more complex models. The pace of technological evolution has followed an exponential curve, a pattern mirrored in Moore's law and similar paradigms. This historical perspective illuminates not only past achievements, but also provides a blueprint for anticipating future breakthroughs. Every era built upon the insights and limitations of its predecessors, cumulatively propelling AI closer to the singularity. Examining these historical milestones allows us to appreciate the iterative process of innovation that has driven AI from simple rule-based systems to the sophisticated multi-layered architectures of today. At its core, the singularity refers to a theoretical point when artificial intelligence surpasses human intellectual capabilities, triggering unprecedented changes across all sectors of society and technology. This concept, while rooted in science fiction, has been rigorously analyzed through mathematical modeling and complex systems theory. The central idea revolves around exponential growth in computational power and algorithmic efficiency, a phenomenon that leads to recursive self-improvement in AI systems. A deep technical inspection reveals that the mechanisms underlying this transition are multifaceted. Researchers explore nonlinear dynamics, emergent behaviors, and fractal patterns within neural network layers, which may catalyze rapid advancements. Technical debates center on whether current narrow AI architectures can converge into a unified framework of artificial general intelligence. Concepts such as meta-learning, model scaling, and the integration of symbolic reasoning with deep learning are critical to this discussion. Quantitative models, derived from statistical physics and information theory, offer predictions ranging from decades to centuries before the singularity might occur. Several theoretical frameworks have been proposed to understand the singularity. Some scholars utilize differential equations to model the acceleration of intelligence growth, while others lean on machine learning benchmarks to estimate performance improvements over time. The early successes in reinforcement learning and probabilistic programming serve as empirical evidence supporting these models, suggesting that AI may soon evolve beyond predefined operational limits. Precise numbers and projections, though varied, indicate that the tipping point is not merely a sudden leap, but the inevitable result of a compound growth process. By scrutinizing the underlying principles through a technical lens, we gain insight into how advanced algorithms, computational resources, and innovative learning paradigms converge towards a singular future. This discussion does not merely dwell on abstract theories, but integrates rigorous analyses and empirical data that collectively frame our understanding of an imminent, transformative era. Expert predictions regarding the timeline of the singularity vary widely, but many agree that exponential trends in AI development suggest it could occur within this century. Researchers combine computational benchmarks, probability models, and historical data to forecast key inflection points. Some projections rely on scaling laws observed in deep learning progress, while others factor in hardware limitations and energy consumption estimates. Prominent theories in the field include Kurzweil's law of accelerating returns, which posits that exponential growth in information technology will eventually lead to a critical threshold of machine intelligence. Other figures argue for a more cautious view, emphasizing the complex interplay of hardware constraints, software complexity, and socio-political factors that might delay the advent of a true singularity. Technological drivers behind the potential singularity extend beyond incremental increases in processing power. Innovations in quantum computing, neuromorphic architectures, and advanced neural network models are rapidly pushing the boundaries of what is computationally feasible. Significant breakthroughs in unsupervised learning, transfer learning, and reinforcement learning have contributed to machines' ability to learn from smaller datasets with greater generalization capability. Furthermore, the integration of distributed computing and edge processing has enabled real-time data processing on unprecedented scales, thereby accelerating the feedback loops essential to recursive self-improvement. The concept of recursive self-improvement represents a pivotal turning point. Once AI systems can autonomously upgrade their own architectures and algorithms, the progression may shift from periodic breakthroughs to continuous acceleration. Current research in meta-learning and automated machine learning is paving the way for such developments by enabling systems to optimize their performance without human intervention. Critical thresholds identified in predictive models serve as early warning signals, allowing researchers to monitor when particular technologies may approach or surpass human-level cognition. Together, these predictive models, theoretical frameworks, and technological trends provide a data-driven basis for understanding the trajectory toward a post-singularity era. By uniting interdisciplinary research from fields such as computer science, physics, and complexity theory, experts are developing more sophisticated models and simulations, which not only enhance our predictive accuracy, but also illuminate the nuanced interplay between technological capabilities and societal evolution with precise metrics. Anticipating the singularity brings a wide array of implications across multiple spheres, each demanding careful scientific scrutiny and policy consideration. Economically, the shift towards superintelligent systems could revolutionize industries by automating complex decision-making processes and optimizing supply chains with unprecedented precision. Advanced algorithms may replace traditional human labor in sectors ranging from finance to manufacturing, while simultaneously creating new opportunities for innovation, particularly in research, development, and creative domains where human intuition remains valuable. On a societal level, the integration of AI capabilities into day-to-day life might recalibrate human roles and redefine social structures. Educational systems would need to evolve rapidly to include data science, ethics, and human-computer interaction as core subjects. As we approach a threshold where machines begin to execute tasks with higher reliability and efficiency than humans, new social contracts might emerge, ensuring that technological dividends benefit broad demographics rather than a select few. Politically, the rise of superintelligent AI poses both opportunities and threats to governance systems worldwide. While enhanced data analytics could lead to more informed policymaking and efficient public services, the same technology might also be weaponized in cyber warfare, surveillance, and manipulation of public opinion. International regulatory frameworks, ethical guidelines, and robust security protocols will be vital in managing these risks. Opportunities arising from the singularity are vast and multifaceted. Breakthroughs in healthcare, for instance, could be accelerated by AI-driven predictive diagnostics, personalized treatment plans, and streamlined medical research. Environmental management could witness improvements through smarter resource allocation and real-time monitoring of ecosystems. In scientific research, AI might enable the discovery of novel materials, elucidate complex biological systems, and solve long-standing mathematical problems by sifting through massive datasets with efficiency beyond current human capabilities. Integrating human values within these technological advancements is not merely an ethical necessity. It is also a pragmatic strategy for ensuring that benefits are shared equitably. This new era of AI could radically redefine how we approach fundamental challenges, such as climate change and global inequality. With data-driven insights, decision-makers may adopt more precise and targeted interventions, ultimately leading to an improved quality of life. However, success hinges on the collaborative integration of technical innovation with sound policy, ethical governance, and an inclusive vision of progress. As we stand on the brink of this transformative epoch, it is incumbent upon researchers, engineers, policymakers, and society at large to ensure that the journey toward the singularity results in meaningful, sustainable progress for all. Long-term planning, interdisciplinary collaboration, and reassessment of technological impacts will be essential to navigate this transition effectively. Assessing the risks of a post-singularity world requires a systematic evaluation of ethical dilemmas and technical vulnerabilities inherent in advanced AI systems. Primary concerns center around the possibility that superintelligent machines might act in unpredictable ways. An AI that improves itself at exponential rates could eventually evolve beyond human control, raising questions about alignment with human values. Many experts stress that without robust safety measures, the race for AI advancement may inadvertently sideline necessary precautions. Ethical dilemmas also abound. Issues such as inherent biases in training datasets and the opacity of deep learning's decision-making processes pose significant questions regarding fairness and accountability. As AI systems take on decision-critical roles, ensuring transparency in algorithms and establishing traceability of reasoning become imperative. Discussions in the field increasingly focus on embedding ethical constraints directly within AI architectures to preempt harmful outcomes. Potential pitfalls extend to security vulnerabilities as well. Superintelligent systems might be prime targets for cyber attacks, manipulation, and exploitation. The dual-use nature of AI technologies further complicates the matter, as innovations meant for societal benefit could be repurposed for malicious ends. Risk scenarios include emergent behavior that was not anticipated during the design phase, leading to cascading failures in interconnected systems. Preventative approaches, such as adversarial training and formal verification methods, are actively being researched to mitigate these challenges. The debate between AI autonomy and human oversight persists as a central issue. Although autonomy can drive rapid innovation, it also increases the likelihood that AI systems operate without sufficient checks, thereby amplifying risks. Strategies to counteract these dangers include developing kill-switch protocols, layered oversight mechanisms, and continuous monitoring frameworks that detect deviations from expected behavior. Integrating ethical governance with technical safeguards is critical to preempt catastrophic outcomes. In summary, while the frontier of advanced AI presents vast opportunities, it also necessitates a cautious approach to balance innovation with necessary restrictions. Comprehensive risk assessments, coupled with proactive policy measures, can help ensure that the evolution of AI aligns with broader societal interests and safety imperatives. The potential consequences of neglecting these factors range from economic disruption to existential threats to humanity. Meticulous attention to ethical details and rigorous technical standards will be indispensable as we navigate this challenging landscape. Future research must prioritize developing robust, verifiable frameworks that can simultaneously monitor, control, and adjust AI behavior in real time, ensuring that unforeseen risks are mitigated and ethical boundaries are respected consistently for future safety. In wrapping up our analysis, it is clear that the prospect of the singularity is both an invitation and a challenge. Our exploration has traversed the historical foundations of AI, delved into the technical dimensions of exponential growth and recursive self-improvement, and scrutinized the multifaceted predictions that frame the future of machine intelligence. With advanced mathematical models, rigorous simulations, and empirical data at the heart of these forecasts, experts are better equipped to understand the likely timelines and transformative impacts. We have examined not only the monumental opportunities that advanced AI presents, but also the significant risks and ethical dilemmas associated with a future dominated by superintelligent systems. From economic restructuring and societal shifts to complex international governance issues, the implications are as profound as they are far-reaching. Continuous dialogue among researchers, engineers, policymakers, and the global community will be essential to align technological progress with shared human values. Looking ahead, the future of AI is not predetermined. Instead, it is shaped by our choices, innovations, and the frameworks we establish to harness these technologies responsibly. Embracing a balanced perspective that recognizes both the potential for breakthrough advancements and the need for stringent safeguards is the path forward. Critical research, agile policymaking, and multidisciplinary collaboration will all play pivotal roles in determining whether the singularity evolves as a triumphant milestone or a profound challenge. Our journey into this uncharted territory must be guided by scientific rigor, ethical foresight, and collective wisdom to ensure that progress benefits all of humanity equally. As researchers continue to decode the complexities of advanced AI, every breakthrough serves as both a